Bismillahirrahmanirrahim. In this video, I will explain on principle of electromagnetic induction. So what is electromagnetic induction? Electromagnetic induction is a process whereby an EMF, electromotive force, is induced in electrical conductor when the magnetic flux linking the conductor changes. So this can be demonstrate by using this simple homemade apparatus. This is the magnet. Okay, a magnet. This is a coil of wire or solenoid. It's actually complete circuit with the connected to the galvanometer. So this is the pointer of galvanometer. Okay, what is galvanometer? It's a device to measure EMF or current flowing in the circuit. Okay, it's either to deflect to the left or to the right to show that current being induced in the circuit. Okay, so if a bar magnet or if a magnet bring close to the solenoid, the galvanometer will deflect is either to the left or to the right. This shows that current being induced. Again, if the magnet move away from the solenoid, it shows opposite deflection. So again, it shows that current being induced in the circuit. Okay, or the magnet stay at rest or stationary, and the coil or the solenoid move towards the magnet. It shows deflection here. It also shows deflection here. If you move it away from the magnet, it also shows deflection here, opposite the deflection from the first one. Okay, but if both of them does not move, okay, there's no deflection. The pointer stay at the middle, 0. Okay, or both of them move at the same direction and the same speed. Okay, it will not show any deflection there. Okay, Faraday law. What is Faraday law? Faraday law in electromagnetic induction states that the magnitude of induced EMF in a conductor is proportional to the rate at which the magnetic field lines are cut by the conductor. Okay, so how to increase the size or the magnitude of induced EMF in the conductor in this solenoid? So first, you can either change the magnet into a stronger magnet. Okay, increase meaning increase the strength of the magnet, or you can increase the number of coils here, number of turns on the coil. For example, this one 1 2 3 4 5 6 7 8 9 10 11 12 13 number of turns. So maybe you 16 15 or double it, 26 turns. Or you can increase the speed of the magnet, okay, into or out from the solenoid. Okay, that's the three factors that affect the size or the magnitude of induced EMF in the circuit. Okay, so the second one is Lenz law. It's also very important. So Lenz law in electromagnetic induction state that an induced current flow in a direction such that the current opposes the change that producing it. So this one, you need to use your right hand to determine the direction of the current and to determine the polarity of the solenoid. Is it north pole or south pole? So what is mean by Lenz law? If this is a magnet, this is the solenoid connected to the galvanometer. If you move the magnet towards the solenoid, okay, this part or this end of the coil, this end of the solenoid, try to induce north pole. Okay, why? Because this is moved towards, so it want to oppose the change that producing it. Okay, so it must induce north pole, it must repel. Okay, so this one is moved towards, this end must produce north pole to repel it, to move away from the solenoid. Itulah ia oppose the motion. If go to the left, it must go to the right. How to go to the right? How to move away? How to make it the magnet move away? So this polarity must be north pole to repel it. So what is the direction of the current using the right hand grip rule? So right hand grip rule. Okay, so the direction of the current in front of the coil must be downwards. Okay, downwards. So this is north pole, so this is downwards, this is up, so downwards, so it will deflect to the right. The galvanometer, pointer of the galvanometer will move to the right. Okay, so if you use a south pole, it will shows opposite direction. Deflection is opposite to the left. Okay, same with withdrawn the magnet here. If you withdraw the magnet, okay, at the O, move away from the solenoid, so the coil or the solenoid try to make the magnet move towards it. So how? It must, this end must induce a south pole. Okay, south pole to attract. So this one macam repel kan, ni move away. According to Lenz law tadi, okay, the induced current flow in a direction such that the current opposes the change that producing it. So ia oppose. So this one is move away. So the solenoid tend to make it, the magnet move towards it. How to make it move towards it? So this end must be south pole to attract it back. Ia move away kan? Ia mau move towards. So this must be south pole. So again, using your right hand grip rule, okay, how to make this is south pole, so this is north pole. So upwards here in front of the solenoid, okay, the direction of the current show upwards. So upwards, this one is moved to the left. The pointer of the galvanometer move or deflect to the left. Ia sekejap saja tu, deflect then go back to zero. Kalau sudah jauh, go back to zero. Okay, so that's Lenz law. Again, Faraday law is to determine the size or the magnitude of EMF being produced in a conductor, whereas Lenz law is to determine the direction or the flow of the current in the conductor. Okay, so that's it.